Alright, today we are going to continue from where we stopped in tutorial 4, where we are discussing operations in Python. We've covered the first 5, and today we are going to be looking at bitwise operators, membership operators, and identity operators. I'd also like to remind you to subscribe to my channel by clicking on the subscribe button, so you subscribe if you've not subscribed before, so that you get notified when I make new lessons. Alright, so I've written 2 binary numbers out there, and the binary numbers is actually 0, 0, 1, 1, 1, 1, 0, 0. So the prefix 0b indicates that it is a binary number. So what is going to happen is that we can easily start working on binary operations. So let's start with ANDs. Let's start with AND. We are saying that AND operator evaluates to 1 when both bits are 1. So when we have 0, 1, 0, 0, 1, 1, and so on. So we can only have 1 when it is 0. So what it means is that we have C is equal to A and B, right? So what I think C is going to be, it's going to be 0, 0, 0, 0, right? 1, 1, 0, 0. So the 1, 1 here, it means that these 2 places where they are 1, it becomes 1. So let's try to see how it goes. So I'm going to print C. I'm going to print C. Now look at what is going to happen. It's going to print out a decimal number, which is 12, right? So the reason it's printing out a decimal number is because it takes the variable to be an integer. So to print out the binary equivalent of it, simply use the function bin. So when we use the function bin, it prints out the binary equivalent of it. So at this point, we have 0b, you have 1, 1, 0, 0. So kind of Python truncates the first 4 zeros. And of course, these first 4 zeros are not meaningful. Alright, so let's now look at OR. So if we have D is equal to A, so let me see if I can get the symbol on my keyboard, A or B, right? So in the OR, in the case of OR, let me take out one of these comments. It evaluates to 1 when either of the 2 bits is 1. So when we have 0, 0, when we have 0, 0 is 0. But when we have 0, 1 or 1, 0, it becomes 1. So if we do it for this, what I think is going to be 0, 0, right? 1, 1, 1, 1, 0, 1, right? So I'm going to print out D and let's see how it's going to look like. And of course, Python is going to throw away these 2. So what we expect to see on the printout is 0b to represent the binary and then 1, 1, 1, 1, 0, 1. So I'm going to run it and let's see. So you have 0b, 1, 1, 1, 1, 0, 1. So the key is that for this operation, it actually takes evaluates to 1 when either of them is 1. Let's now take the next one, and that is this operator, which is actually the XOR, exclusive OR. So let's say E is equal to A XOR B. So what does it do? This evaluates to 1 when one of them is 0 and the other one is 1. So when both of them are 0, it evaluates to 0. When both of them are 1, it evaluates to 1. It evaluates to 0 as well. So it becomes 1 only when when 1 is 0 and 1 is 1. So when we evaluate on this, the E is going to give us, I think it's going to be 0, 0, or 1, 1, 0, 0, 0, 1. So of course Python is going to do away with the first 2 zeros, so we have 0b, 1, 1, 0, 0, 0, 1. So try to get your head around it and make sure you understand how it works. So I'm going to print it out and let's see. So you have 1, 1, 0, 0, 1. So this is the XOR. This is the XOR, so it's the same as X. And this is what the OR. and this is AND. So let's look at the other one. This is a NOT. So if we have F, let me just take out this, just continue. You can pause the video if you want to make notes. You can pause the video or rewind it and copy what I just deleted. So let's try to use the NOT operator. The NOT operator actually negates what is there. Changes 1 to 0 and 0 to 1. So how to use it is simply to specify it. Let me see. Yeah, specify it in this way. So what it's going to do is going to flip. So it's going to flip the bits. So anything that is 0 is going to be 1, and anything that is 1 is going to be 0. So when we flip A, it's going to become 0, or it's going to become 1 1 0 0 0 0 1 1. So this is exactly what we are going to have, and Python is going to add 0b to indicate that it is a binary, and then I'm going to run it and have 0b. What do we have? So C. Okay, so we have to print C, not A. All right. So I run it now. We have some problem. So let's see. Hold on. Let's see. 0b 1 1 1 1 0 1. So 0b C is equal to flipping A. So we have 1 1 1 1 0 1. Okay, so it's adding a negative number, which is kind of strange. Okay, so C is equal to flip A. Okay, minus. So why is it giving us minus? Okay, we fix this. Let's work on the shift operator first, then we continue on this. So the shift operator also works in the same way. So we have 0b, we have 1 1 1 1. When we shift it to the right, it's going to shift it to the right exactly. So what it's going to do is, let me just explain it. When it shifts to the right, it kind of moves these numbers to the right and then adds 0 to the spaces that are created, more like you are shifting Excel data in Excel cells. So let me do it so that we now explain the result. So we have B shift right by 2. Let's shift it. Okay, let's shift it right by 1, and then we are going to print out B, and let's see C. So C is equal to B shifted right by 1. You have 1 1 1. So when we shift B to the right, it kind of becomes 0 1 1 1. So it throws away this last bit in there, right? So it shifts it to the right, meaning that one bit falls out from the edge. So if you are looking at this like an edge, this bit falls out because it's shifting to the right, and we only have 3 ones, and the space created at the other side of it becomes 0. That is why we have this. And in the same way, if we have shift left, is a bit different. In this case, it's going to shift to the left, and then it adds 0 to the other side of it. So if I run it now, you can see that it shifts to the left. In this case, when it's shifting to the left, it's not throwing away anything, and then we have 0 added to the extreme. So if we have 0 at the left, 0 at the left side, that 0 is thrown away. But if we have 0 at the right, that 0 remains. So what it means is that, let's take for instance, I want to print out, let's say C is equal to 0 0b or 0 1 1 1. Let's say D is equal to 0b, and we have 1 1 1 0. So in this case, in the first one, this 0 is going to actually be thrown away, but this 0 will be preserved. So hope you got it. So let's now look at the next one, the membership operator, and that is also a bit easy to understand. So let's say this one now depends on having a list. So if you have a list, list1 is equal to, we want to check if certain numbers are in the list. 4, 5, 6, 7. So what I'm going to do is to say, I can easily say 12 in list 1. So what it's going to do is going to check if 12 is in list 1. And if it's 12 is in list 1, it prints out true, else it's going to print out false. Print out 12 in list 1. So we are having error message. Invalid syntax. Okay, we have error in this place. Alright, so I'm going to run. So for sure 12 is not in list 1, it's going to give us false. So let's use is 4 in list 1. Going to give us true. So let's use 12. Is 12 not in? So in this case, it's going to be true because 12 is not in list 1. So we basically covered all the operations in Python, and then the next thing we are going to do is the identity operator. So this is and is not. We actually need to discuss object-oriented programming in Python before we are able to understand it, because this is used to check if an object is member of a class, right? So we are going to do that in the next subsequent tutorial, not the immediate next, because we are going to be discussing decisions and conditional statements in the next lesson. But later on, we are going to do object-oriented programming, and we are going to cover identity operators. I'd like to thank you for viewing. Leave a comment if you have some challenges. Remember to subscribe if you've not subscribed.